everyone. So today we are going to talk about the ML project that I'm going to work upon. It's basically in the life science industry, where we are going to prioritize HCPs based on the adoption and the prescribing capacity of the HCP for each and every sales rep. So the problem right now, main problem right now in the life science industry is it's for a sales rep, it is very difficult to prioritize which SCP he or she should meet, and in order to improvise his sales target. So the ML project that I'm trying to demo over here helps in prioritizing HCP, which will indirectly help in increasing the sales target of reps. So let's move on to the first slide. Okay, so as I've mentioned, the high level context. So the context over here is helping out sales team in life science industry to prioritize HCPs with whom they should engage first, and how much time they should spend, and identify the HCPs which are most likely to prescribe and adopt a product. Let's talk about the opportunity that we will have over here. Once we implement this ML solution, the value that we will get is like the organization will help organization improve its sales targeting and convert the HCP. So our conversion rate will increase. Even with a small increase in this prescribing methodology, it will drive the revenue growth. Now, in order to have this ML model in place, we have done some feasibility analysis, and based on the data that we have, we can use for our ML model, we can use our historical sales information of the HCPs. We can analyze their CRM logs, what kind of activities they do on the CRM, and their profiles. This will help our models to predict and prioritize HCP in a better way. Now, in terms of action, this will help and give sales rep a clear guidance whom they should prioritize and focus upon, and this will help definitely in increasing their what we can say, they will increase their sales target. Now let's understand the business that we are trying to achieve over here. We have to improve the sales efficiency by identifying HCPs most likely to prescribe, and which product they should prescribe and which HCP they should target, so that they can complete and achieve their targets during the particular period. Now our goal over here is we need a model which will rank HCPs based on their historical activities, the data that we have. We will have to identify and rank such HCPs which are most likely to prescribe our product or adopt our product. So this is our main goal. Now the success criteria, we can say the outcome will be if this model goes in live on production, this will definitely help organization in increasing their sales and the prescription outcome. So this will definitely help in improving their profitability. The output will be like as I mentioned over here, we'll have a high model accuracy, precision key, and lift over baseline. The key factors that will be used or that will be in this entire project will be the historical prescription, what kind of specialty that HCP or HCO has, what kind of practicing, how much practicing that HCP does, their CRM interaction, which region they belong to, and how how easy the access to the product that we are going to sell to HCP is very likely to that HCP. So these are the key factors which will drive and help groom our ML model. Let's go to the validation. So for validation, we will have some different types of validation that I have thought of. One will be our offline testing, definitely, which will, what we will do over here is we will train our model on the historical data, and we will compare the model accuracy. Then we will do a pilot test. We will pick a small sales team, maybe of a particular territory or a particular region. We will deploy this model on on that sales team's data. We will gather feedback, and we will see what is the impact over there, and track the prescription up, whether it is increasing or there is any improvisation in the prescription. The other way, post that, once we are done with the pilot test, we will do a A/B testing, which is nothing but the model that we have generated. We will compare the targeting, whatever ranks the model gives us, the HCP ranks, we will target with the traditional approach that currently we are following, maybe on the region or a particular rep, or for a particular rep, and we will see, we'll compare the traditional approach with the output that our model gives. Once we do this, we will keep on improvising model based on the feedback and the results that we will get from this testing, and we will keep on refining our fresh features, thresholds, and keep on retraining the model. So this is the approach we will follow for the validations. Let's go to the next slide. Talking of the high level design, or definitely it will be a cloud-based architecture, where we will have a centralized data which will be there in the centralized place. Our training model will be scalable, and it will be easily integrated with the CRM tools that our organization uses. The strategy, of course, we will have to keep on training the model. So we will apply and will adopt an offline training model, where maybe every week or every month, with the new data that we will receive, we will keep on training. We'll keep on training the model that we have, that will make our model stable and more reliable. The prediction mode. Now we are training our data. We are getting our new data. We are continuously training our models. We will predict the HCP. Maybe every night we'll have a batch prediction, where on a night basis we will keep on refining the ranks of the HCPs for a particular rep, and we will plus an on-demand scoring for any special queries that we have. So now why this design? So if we talk about the the impact that we will have, is we will ensure that we have a scalable design. There is a low latency over here. The models will be able to explain why this how this ranking came up, and there will be a very smooth integration with the sales workflow, so we can have the workflows as and when needed. Last, we have identified couple of risks over here, majorly around 5 to 6 risks that we see, but that we foresee over here, like the data drift, that then can be changes in the HCP demographic and the prescribing patterns, so that may reduce the model accuracy. There will be a concept in new drug launches, competitor drugs, updated medical guidelines, or policy changes in the particular region or territory that might impact the prescribing behavior. There will be a skew, difference between the training and the live data pipelines, which may generate inconsistent results. There may be a decay in the calibration. Predicted probabilities may be less reliable over time. because of the change in the data drift and concept drift. Then we will have a compliance. We may have a compliance risk. We must ensure that the data is private, data privacy is adhered. It is explained, and whatever output or input that we are providing to model, it is as per the pharma regulations of that particular region. Now, of course, we'll have to come up with a mitigation. So we'll have to keep a tab on monitoring that model. We will keep on retraining the model as and when needed, or on a scheduled frequency, and we will keep on validating against the real world outcomes. So that's the overall risk that we have identified, and that brings the end to my presentation. Thank you.